Welcome to my excellent example. Okay, so the experiment that we want to write first, I'm going to assume you've read the question. The experiment is to select a random egg from a random carton. So that means carton first, then egg. So let x be the number of broken eggs, broken in the carton, and b is equal to eggs selected being broken. So for the tree, I'm just going to draw what's known as a partial tree. The lazy man's tree, but you should draw the whole thing. So we have, firstly, that we're going to select a carton. And what type of carton? We have those with no broken eggs, those with one broken egg, those with two broken eggs, those with three. I'm going to draw a dotted line with x bigger than 4, but in the question this said it was negligible chance. So it's not really there. From the question we have that the percentages are 0.785, 19.2% have one broken egg, so 0.192, and similarly 0.022 and 0.001. So it's very unlikely to pick up a carton with 3 broken eggs in it, but there's going to be more broken eggs to choose from. And so what's the likelihood of getting a broken egg given that you picked a carton with no broken eggs in it? Well, that's 0, right? So with one broken egg, you get 1/12. The reason I call this a partial tree is I'm not drawing in like b bar and 1 because it's just going to be the complement. Similarly, the more broken eggs I have, assuming equally likely chance of selecting a random egg, see the randomness means equally likely. And so if I work out the total probabilities along these branches, I get 0. 1/12 of 0.192 is roughly 0.0160. 0.0037 and 0.0003 for a total of about 0.020. Okay? In fact, even to 4 decimal places. And so finally what we want to compute is that probability, so we ask, an egg is selected at random from a carton is found to be broken. What is the probability that this egg is the only broken one in the carton? So that's what we're asking. We're asking the probability that x is equal to 1, that is, we find one broken egg, given that we found a broken egg, so given b. So this is equal to the probability of x equals 1 and b, all over the probability of b. Remember this thing at the bottom, this was probability of b. And that's equal to, well, which one is it that we want? It's this one, right? So one egg is found to be broken, and we managed to pick the broken one. As a remark, note that this number, the probability of b, is actually quite a small number. The probability that you actually get a broken egg is not very high, but of those, it's dominated by the boxes with 1 in it. So this is about 0.803. So if you did find the broken egg, it's likely to be the only one in the box.